to blockchain and cryptocurrency. So, yes, as it may seem very apparent from the topic, it is sort of an introductory lesson towards the world of blockchain. We'll be looking at what is a blockchain, what are its components, algorithms. We'll also visualize it with an online tool. And after this session, Aniket, my co-speaker, will be taking up a coding session where he'll be showing you guys how to set up your own cryptocurrency. So also please do note that this webinar is part of a series of weekend webinars which BitGrit conducts. So if you want to join in for future webinars, then you can sign up on the meetup link, which is bit.ly/bitgrit meetup. So you can actually be notified of future events as and when they happen. You could also join BitGrit's Telegram group, which is called BitGrit Data Science Community. So let's begin. I hope you can see my screen. And if you cannot, please do let us know in the chat box so we can actually resolve that if we have any issue. I hope you're seated comfortably. So on that note, let's begin. Hi, I'm Ritom, campus ambassador for BitGrit at MIT WPU Pune, India. Welcome to BitGrit's webinar on the topic Introduction to Blockchain and Cryptocurrency. So I personally have read up a whole lot on the entire blockchain scenario and all the exciting prospects which it presents as its applications. I've also actually seen many people who tell that the blockchain is sometimes too clunky or it is sometimes very inapplicable to any real world solution. However, the underlying technology which runs blockchain and the vision with which it was created, that is what actually intrigued me. So that is what I'll be trying to show in this webinar. I personally am a data science enthusiast, and I've also done web and app development in the past. I'm also one of the head organizers at the Script Group, which is a community of tech enthusiastic students. Now, during this session, I would actually request each one of you to kindly put your microphone on mute so that there is questions up whenever one of our members is actually free or at the end of the webinar. So let's get started. Sit back, relax, and enjoy it. Democratized information, right? But when it comes to assets like money, stocks, bonds, loyalty points, IP, music, art, vote, credits, so sending you a copy is a very bad idea. So if I send you $1,000, it's important that I don't have the money with me anymore. And this problem is essentially what is called the double spend problem, which was taken up by cryptographers very early on. So this is to avoid this problem is why we have banks or financial institutions in whom we trust, and we give our money to them for safekeeping. But in blockchain, Reserve Bank of India with a digital signal, so we can change it out. Also, the blockchain allows the all the network participants agreement, which is commonly as a third party, like we were having banks initially. In this technology, there is no third party, yet the chances of any fraudulent activity or duplication of transactions is actually eliminated without the need of a third party. Right. So coming to the second topic, which is security. So we did discuss briefly how security is maintained in the network. We'll actually look at it with more depth in this section. Right. So security. So taking the Bitcoin example, if you know Bitcoin, it was one of the first cryptocurrencies which came into existence. We'll also be looking at Bitcoin, in fact, why that kind of a system theoretically have to do because the whole topic fingerprint is called a hash. So this takes in and we generate actually it's actually service proof made and we need to verify whether the hash matches the block or not. This is comparatively easier, and once the nodes have done this, they can actually update their own respective copies of the blockchain with the new block. So that is basically the consensus protocol. And that also is a contributing factor to the security of the whole network. And the third thing is the hashes or the fingerprints, which we were talking about in the first point. These also serve as links in the blockchain. So each block actually includes the previous block's unique hash. So if you want to change an entry in the ledger, you will have to calculate the new hash for it and also for every subsequent block. You will also need to do this fast enough, otherwise your blocks will actually end up conflicting with existing ones, or other nodes will actually reject your alteration. So this is what actually makes the blockchain tamper proof or immutable. So this is a diagram which I found. It is kind of very it is a nice explanation. So as you can see, the first block is a genesis block, which is basically the first block which is created in the network. So we have a hash of that, which is 4x8g, and the previous hash is 0010. Also, it is sometimes taken as just zero because there is no block before this, so that won't have a hash either. This is connected to, so suppose a new block has to be made. So some data is put in and that block is generated and it is put onto the blockchain. So this block's hash will be generated, which is 3LFK, and there will be a link back to the previous block. As you can see, this 4x8g now appears in the previous hash field of the second block. So 4x8g is the previous hash of this. Similarly, for the third block, though suppose the hash generated is 85ks, the previous hash will be the hash of the previous block, which is 3LFK. So 3LFK comes in here. So this is basically the hash's link back point. So the fingerprint which we talked about in the first point is this hash function. Though in the Bitcoin, it is the SHA 256 along with hash cash technique which is used in Bitcoin. So that is how a hash is generated in Bitcoin. The consensus protocol is basically this kind of a chain will be generated by all the miners and it will be verified. And if you have a consensus, which is basically a majority that yes, this calculation is correct, that will actually be put onto the blockchain network. Again, the third point, hashes link back, as we said, the next block always links back to the previous block. And yes, this system is not actually attack proof. So we can say that yes, it is secure enough, but there are ways to cheat this system. In fact, one of the very famous examples is the 51% attack rule. So if you somehow manage to get access to the 51% of the network, then you can actually uh, influence the network in a way that only your transactions will be always validated and all others will be uh, ignored. So yes, there are chances to attack it, but it is like a very remote chance as such. Okay, so this is a site. We'll look at this. This is basically an online visual tool. So I'll just start this. Yes, can you see the screen, the blockchain screen? Aniket, is it visible? Okay. Okay. Yeah. Okay. So yes, this is an online tool basically. So this is the first block which you see. This is the Genesis block. Okay. So Genesis block is essentially the first block which exists on the network. The previous hash is zero because there is no block before this. And the data which we have put in fact, the creator of this website has put in by default is welcome to blockchain demo 2.0. And that hash is created in this, right? And that this is stored in this block along with the timestamp. So you can see this timestamp, which is like randomly generated for now. It's 17th October 2017, for example. And this number is the nonce. It's 604 is like a number which is appended to the data, and that data along with the timestamp and the index ID of this block together actually makes up your actually takes part in the hash generation. So in fact, you'll always have a different hash no matter what, and it is truly randomized in that sense. So this is one block. So I'll just make a new block here. So let's just say, welcome to BitGrid. So I'll add this new block. So yes, as you can see, we have made a new block here. The previous hash, so this hash becomes the previous hash of this block. And welcome to BitGrid. This data, this index, timestamp, and this nonce 5496 together helps us make this new hash of this particular block. Okay, so similarly, we can actually, keep making blocks, and this actually keeps being added onto the network in order. So let's make another block. So let's just put hello. Right. So even in this, you can see the previous hash is this hash 0097, starting with that. And again, this current hash is 00016E9A. That one. So now we have three blocks on the network. Now the interesting part is, now suppose someone wanted to tamper with this block. Okay, so he manages to change this data. So he says, he suppose adds here the string. So as you can see, as soon as I change the string, this hash has now become invalidated, right? So this became red. And because of this becoming red, even the next block became red. So it is something like you invalidate one block, you manage to thus invalidate the rest of the chain. And because of this, now all the blocks from this to the end of the chain has to be remined. So this button actually will help us to recalculate this hash, which basically like remining the hash, right? So this is now the corrected hash which we got, along with the even the nonce has changed so to 300 now. And now we need to do change this or remine this. So let's do it. And yes, now we have got the correct hash value. Yes. So yes, now as you saw that the changing one record actually breaks the entire chain as such. So this is kind of the security which we were talking about earlier, in which that if you break the chain and then you try to put it onto the network, unless and until you have a majority of that calculation. So for example, here there is only this one guy Satoshi who's calculating this. So suppose you have more peers here, okay, and even they were calculating the same thing. Now I managed to change this to everybody, but the second person in his chain, that will still be the original message, right? Welcome to bitgrid. That would have remained in his chain. Even for like a third person or a fourth person, they would continue to have that same data. So I personally cannot affect the blockchain as such, because I individually don't have the majority. And this is why there is the 51% rule, that if I somehow manage to influence 51% of the network, I can somehow get control of the network, because I can actually then tell everybody to change the message, remine it, and then add it onto the network, just because we all 51% of us has the same results. In that case, the blockchain is untampered with. But actually doing that on a very large scale is kind of the situation which contributes to the secured aspect of the blockchain, because talking to 51% of the network itself is a very big pain. In fact, with millions of miners and even more than like 2 million 3 million transactions on a blockchain network, it is very difficult to gain access to 51% of the network. Okay, so yeah, so I'll come back to the presentation now. Okay, is my presentation visible now?
Yes, sir.
Okay, sure. Thanks. Okay, so we looked at the blockchain and how it works, how the hashes are made. In fact, we have an example also coming up, so you need not worry about the whole calculation part of it. So let's just look at this cryptocurrency section, right? So one cannot have a discussion on blockchain and not cover cryptocurrency in any way. So we'll explore how the blockchain exactly is present in a cryptocurrency network, and we'll talk about crypto in this section. Okay, so of course we cannot have a discussion also on cryptocurrency without mentioning Bitcoin and the author Satoshi Nakamoto. So this is the abstract of the original white paper which was submitted back in 2008. This was entitled Bitcoin, a peer-to-peer electronic cash system. Right. So the protocol described here actually represented a cryptographically secured system, like what we were saying as encrypted and having digital signatures or hashes or fingerprints. So it is secured cryptographically, and it is based on a proof of work algorithm in which the bitcoins or BTC are mined for a reward by individual nodes, and then all that mining is verified by other nodes in a decentralized network. The paper also explains the whole working, and you can, if you have the PDF, I sent the link in the chat earlier. So if you click on this PDF, you can actually uh, download this paper and read through it. It is a very interesting read. In fact, the whole technology is explained pretty well here. So I hope you'll find it very interesting. If you can read this after the webinar is over. Okay, so what is a cryptocurrency? Okay, this exchange rate is yesterday's rate actually. So one Bitcoin equals 7545 USD. So yes, if you own one Bitcoin, you are very rich. But that is not always the case, and I'll tell you why. So before that, a cryptocurrency is essentially a digital asset, right? It is present digitally. You do not have a physical Bitcoin in your hand. It is designed to work as a medium of exchange, and this exchange medium actually uses very strong cryptography to secure your financial transactions, and it will also control the creation of additional units and verify the transfer of assets and all that. So cryptocurrencies use decentralized control as opposed to the regular digital currency which we use, right? So the regular digital currency which we use has been like issued, for example, in India, the rupee notes are issued by the RBI, and the transactions and everything is managed by the banks, and the RBI oversees that. So in cryptocurrencies, that is not the case. There is decentralized control as such. So this control essentially works through the distributed ledger technology, which is basically a blockchain, which serves as a public transactional database. And that is where blockchain comes in the cryptocurrency, right? So the blockchain acts as a distributed ledger on which all the transactions are present. Okay. So Bitcoin is actually considered the first decentralized cryptocurrency, and it was first released as an open source software in 2009, which is almost like 1 year after the paper was published. And since its release in 2009, there are over 6,000 altcoins, that is like alternative variants of Bitcoin or other cryptocurrencies, have been created. Okay, and yes, that is the exchange rate of Bitcoin as of yesterday. So one BTC equals 754501 USD. And this rate is what leads many people to believe that cryptocurrencies are the hottest investment opportunity currently available. Okay, so yes, they have a high exchange rate. However, these are also very high risk investments, and their market value fluctuates like anything. Their value fluctuates like no other assets in the market. Moreover, due to its nature of being partly unregulated, right? So because there is this public transactional database, there's a blockchain, it is not always regulated as such, and there is always the risk of the network getting outlawed in certain countries. Besides the chances of the crypto exchange also getting hacked, so you might also have the chance of losing all your Bitcoin assets. Like it is a very significant chance as well. So yes, it is very high risk, yet it is the most promising also for many people. Okay, so I was reading about cryptocurrency yesterday, and I found out 6 conditions that a cryptocurrency needs to follow. Right, so cryptocurrency is basically a system which will meet all these 6 conditions. Right, so the system does not require a central authority. There is no central authority, and its state is maintained through a distributed consensus or a distributed majority. Right, so system keeps an overview of the units and their current ownership. So basically, which Bitcoin is owned by which person, and what is the wallet ID and all that. So the system actually has to keep a track of that. The system also defines whether new cryptocurrency units can be created. And if new cryptocurrency units can be created, the system then defines the circumstances of their origin and how to determine the ownership of these new units. Okay, and next point is the ownership of the cryptocurrency units can actually be proved exclusively and cryptographically. There is no simple formula to calculate it, right? You need to understand the cryptography which goes behind it, and you need to calculate it in that precise manner only. The system also needs to allow transactions to be performed. So obviously you cannot just have bitcoin in your wallet and sit around. You need to do transactions with it, correct? So the ownership needs to be changed, so you need to be able to transfer bitcoins. So a transaction statement can only be issued by an entity proving the current ownership of these units. So only when it is proved that you have this many amount of bitcoins, only then will you be able to transact and send over that amount to another person. So that ownership needs to be verified, and then the system needs to allow transactions for that. And if two different instructions for changing the ownership of the same cryptographic units are simultaneously entered, so suppose three people simultaneously say that I'm the owner of this Bitcoin, and like this, there are three people. So three people saying, "Hey, I'm the owner. I'm the owner. I'm the owner." So the system will at most perform. The system will perform at most one of them. So more than one, one will be performed, and the other two will be rejected. Now, which one choose? That is the system's decision, depending on the history of the blockchain, and which user or which peer has the more correct records. So all that comes into play at that time. Okay, so coming to the final section, we'll be looking into the proof of work algorithm, which actually backs the whole network, right? So this algorithm is basically what runs the blockchain. Okay, so what is proof of work? It is the original consensus algorithm in a blockchain network. So in blockchain, this algorithm is actually used to confirm the transactions and also to produce new blocks to the chain. So with proof of work, miners can actually, compete against each other to complete the transaction. So miners actually have to calculate the transactions fast enough so that they actually gain rewards out of it. And that is why you now might be hearing of the term mining rigs. So these are specialized hardware fitted with software which actually are just for mining purposes. So these grids or hardware are fast enough and powerful enough to be mining at that scale, and that is what will drive value out of it. Otherwise you'll end up just losing money either for running the electricity costs, or just buying the hardware, but there is not sufficient utilization of that. So in a network, users will actually send each other digital tokens, and a decentralized ledger will actually gather all the transactions into the blocks. However, the system should take care that the transactions are confirmed and the blocks are arranged in the correct order. And this responsibility bears on the special nodes called miners, and that is the process which is called as mining, right? And proof of work imposes some limits on actions in the network. So it gives you defense from the DOS attacks, right? So denial of service, DOS. So they need a lot of efforts to be executed, right? So efficient attack will actually require a lot of computational power and a lot of time to do the calculations, right? So as I was saying earlier, the 51% attack rule, right? So 51% of the network are like out of a million peers and a billion transactions, for example. So all that computational power and all that time to do all that amount, that big number of calculations, uh, is what makes the attack possible, but it is kind of useless for the attacker since the costs are too high for him or her to manage. So 51% attack, so this system is prone to the 51% attack rule, but yes, because there is not enough power to control most of the events in the network, so it is kind of pointless. So there are also the chances of useless computations. So there may be like repeated computations of the same blocks, and miners need to perform a lot of computational work anyways to generate blocks, and this consumes precious electricity power, and the calculations are also done one time, right? So you cannot actually reuse your computations from earlier calculations as such. Every time there is a new calculation to be made, and this cannot be reduced in any case. So that is what makes the system prone to the 51% attack, but doing it in actual like reality is kind of pointless. Okay, so let's take an example. So let's say the base string that we are going to work on is hello world, right? So our target is basically to find a variation of the string, right, whose SHA-256 hash will give you a value which is smaller than 2 raised to 240, right? So your target is 2 raised to 240. You need to find a hash which is lower than 2 raised to 240. Correct. So we have the hello world string here. I'm going to append a number to the end of the string. So firstly, it is hello world 0. Next one is hello world 1. Next one is hello world 2 in that case, right? So we are varying the string while coming up with these combinations. So we are adding this integer 0, 1, 2, 3 at the end. And that is what I've been calling the nonce, right? Nonce, the nonce, and we increment this each time, and thus we get different hashes every time, right? So hello world 0 will give you this hash, correct? So 1312 af178c, correct? So in case I had taken just hello world, you'll realize that only hello world in this string will give one hash. I'll be taking hello world again in that case, in the next case. So that hash would be the same. So that will defeat the whole purpose of the blockchain, right? So we need to have unique hashes being generated. And that is why we are appending this nonce at the end of it. Now, in reality, apart from the nonce, the additional data such as the timestamp, the block ID is also appended. So it makes this hash generation even more randomized. Correct. So this is just to ensure that your hash is coming out differently every time. And we will interpret this hash result here, we'll interpret it as an integer, and we will check if this integer is actually smaller than your target, which I was telling as 2 raised to 240. Okay, so finding a match here. So let's say hello world 0 gave you the value as 2 raised to 252 point something. Hello world 1 gave you the value as 2 raised to 255. Hello world 2 gives you the value as 2 raised to 255 again, along with some decimal points. So similarly, after continuing computations, we end up with 4250 as the nonce, which will give you the value as 2 raised to 239, which is smaller than what target we were setting at 2 raised to 240. Right. So it took us how many tries? It took us 0 to 4250, which is 4251 tries to get this value. Okay. So this 4251 tries is not very much work on a modern computer. In fact, most computers can actually, do 4 million hashes per second. But assuming that the transactions in a network keeps increasing, the generation of unique hashes keeps increasing the computational power which is required. So Bitcoin in its technology actually varies the target. So what I was saying as 2 raised to 240, Bitcoin will automatically keep varying that. So the amount of work which you need to generate a block will also keep varying, but the block generation rate will thus be kept roughly constant due to this kind of a system. So yes, so in Bitcoin, the hash value is also used as a reference to the block itself. So if I tell you the hash of a block is C0000 C3AF, so that will uniquely refer to this block only. And someone might say that the transaction has been mined into the block with the hash so and so. So the header of the block will also contain a Merkle tree, which is kind of another data structure, and that will depend on the included transactions. right? So yeah, so this is essentially an example. So this is what how a block is generated. In fact, this is what we were seeing in that online tool which I was showing you a couple of minutes back. Okay, so traditional proof of work algorithms, there have been proof of work algorithms which have been implemented in cryptocurrencies. So the first one is the hash cache with double iterated SHA-256. This is what is used in Bitcoin. Okay, and then another one is hash cache with script internal hash. This is actually a significantly slower algorithm. It is slower to verify, and the cost of one iteration verification of this script is actually far more than double SHA-256 hashes. So it is actually kind of slower. The third one is called a momentum birthday collision, and the fourth is a cuckoo cycle, and you can find that on the GitHub link which I've provided. So you can visit this link and then you can see the algorithm has actually been posted as code there. Okay, so this is basically the hash cache cost function which will compute one token, and this was used as the proof of work in Bitcoin. This function as such was proposed in 1997, and it was originally meant to be used in a mechanism to throttle the abuse of unmetered internet resources such as email. So if you remember, in 1997 sending an email was a very expensive business, right? So the internet was very limited back then. So to put off the mass mailers or the email scammers, this cost function was used in email so that every email will have a cost associated with it. So email scammers, they'll be sending out emails to a whole list of people, but they'll be incurring that much amount of cost on sending out those many emails. So to put off those scammers is why this hash cache cost function was originally made. And this function, as I told you, it was used in Bitcoin. And if you want to read about this cost function, you can visit this link again, hashcash.org. It is available on that as well. In fact, you can just also put it onto Google and you will get much more information about it. And it is highly intriguing if you are actually into mathematics and cryptography. So you'll find it very interesting in that sense. Okay, so Bitgrit and blockchain. So how does Bitgrit come into this, right? Okay, so Bitgrit essentially is has a data science platform. So if you are into data science, you can actually go onto bitgrit.net and set up an account so you can participate in data science competitions. But you'll be surprised to know that Bitgrit's platform is also built around a blockchain network. So there are three layers essentially. There's the data layer, there's the backend layer, there's the blockchain layer. The blockchain layer of the Bitgrit portal is actually made of three sets of Ethereum ERC20 smart contracts. So Ethereum, as you know, is another kind of cryptocurrency. And the smart contracts, they are namely called as algorithm metadata, data metadata, and transactions and token distribution. So how it works is that once Bitgrit has data and the precise problem to be solved, which is on the platform, the data scientists will actually be competing to create the best algorithm on the platform. Okay, so that success is actually measured by various parameters for specific algorithms, and the data scientist who creates the most accurate result of the solution may be rewarded with grit, right? So grit is a kind of token which is generated in the system, and every time the algorithm which the data scientist created, every time that is sold, sold as in like the source code is given or there are API calls made to the model, the that particular data scientist is rewarded. Okay, so grit is basically Bitgrit's internally circulating utility token, which is a kind of a limited token. So it is limitedly available and it may be used on Bitgrit services, and the distribution model as such is through airdrop and incentive systems, one of which I was just mentioning earlier, that you can win in competitions and thus earn it, right? So you can check out the white paper which I've included in the link here, correct? So using the link provided, you can read more details on the white paper. In fact, it is very well detailed out also. So also, if you are a budding data scientist, so BitGrit has got a talent resume form, which you can fill in so that BitGrit can connect with you for data science related job openings. In fact, this link was also posted on the chat box when we started out with this webinar. So you can, go back to the first chat and get this link. You can fill it in. You will be needing to fill in your interests, your technical skills, and other related information, job related information. So it would be easy for you to get notified about jobs, future competitions, and a whole lot more. Okay, so yes, that was it. Thanks for sitting with me through this session. You can actually follow with me on Facebook, Twitter, Instagram, LinkedIn, or you can just put me up on Google. My profile is available there. You can also click on these individual logos and profiles, and you can then visit my individual social media profiles as such. And if you also want to download this presentation, I had posted the link in the chat box in the start of the webinar. I'll be posting the link again so you can simply download it from that link. So, okay, so if you have any questions, please put them in through the chat box so we can address them. So one of our BitGrid campus ambassadors can actually, address those questions as such. Okay, now that we have seen the crux of the whole blockchain technology, coming up next is a technical session involving coding, and it will be taken over by Aniket Raj, my colleague and campus ambassador for BitGrit at MIT WPU. So do note that those of you who want to have a more hands-on experience in coding along with our speaker, please do have a laptop or a PC with internet connection, a Node.js environment, along with a good enough text editor such as Visual Studio Code setup. So it is actually easier for you to follow Aniket as he takes you through the session. So thank you everyone. Over to you, Aniket.
Thank you, Ritom. Thank you for explaining the basics of blockchain and how exactly a cryptocurrency works. So, getting on to the technical session of this webinar today, we're going to start with building our own basic cryptocurrency system where we'll be understanding how a blockchain works. We'll be using very basic functions so that you guys can easily write minimal amount of code and get a proper product out for you. So before starting with this technical session, I would just like to uh, tell you some basic concepts which were mostly covered by Ritam, but I'll be just taking them once more. So I'll be sharing my screen. Okay, is the screen visible?
Yeah, it is visible.
Okay. So, well, I would like to start off with a little bit of memes because these days memes are sort of informative. So, the value of Bitcoin is very volatile in the market or any other cryptocurrency you guys have ever heard of. So, the reason it is actually very volatile is simply because of the supply demand graph. Those of you are aware of this, that when demand increases, there is a when there is an increase in demand, there is supply as well. So automatically the value or the worth of that particular product increases. So, and those, as Ritam had mentioned earlier, that people spend a lot of money on building these hardwares and softwares which would be efficient for mining, so as to get their reward out of the mining. So why do they exactly do that? Is because there are millions of people who are into this cryptocurrency network. There are people who are competing, who are building better systems, building better code so as to get their reward in time. Because suppose let's take a basic example. A public I would, in a simpler terms, a public list is simply spread to everyone, and in that, I'm sorry, yeah, in that there is a list of transactions which are mentioned. from the sender's account to the receiver's account. All those transactions are mentioned, and the miners, they have to verify that transaction, and whoever verifies it first gets the reward. So basically, that is why people, so since the value of cryptocurrency has increased, people are wanting to, sort of verify those transactions in a quicker way, and that's why they're spending a lot of money on hardware or writing better code. So that is how this meme sort of. I'm sorry, it's a bit pixelated, but this is a good explanation as to how it actually works, how it is going on in the real world. That he feels a great disturbance in the blockchain, which is basically the release of new transactions onto the public notice, as I mentioned earlier in simpler terms. And suddenly, when this notice is distributed to everyone, all those miners, they start up the systems, or they basically start putting all those computation powers, and basically they try to get out those rewards from the system. So as if millions of voices suddenly cried out in terror and went suddenly silent. So basically, once the mining part is done, someone has already received the award, then there is basically no use of doing the same thing which has already been done. So getting on with the hands-on session, I hope you guys had downloaded the required software, not software per se, but required libraries packages, as mentioned in the email. So there was one node.js. Yeah. So I hope everyone has downloaded the required software which is related. So I'll create a file over here. Just open up any folder, and I'm gonna open VS Code. I'm sorry, just one second. So for today, I'll be using the Visual Studio Code editor. I'm pretty comfortable with it, so that is why. And the same link has been sent out to you guys, so you guys can use this. Or if you have any other code editor such as Atom, feel free to use that. So whenever you're writing your code, just open that particular folder. I have created a folder called blockchain. So over there, I'm going to start writing my code. I'll create a file which is main.js, where we'll be writing our actual blockchain code. So the reason I have taken up JavaScript for this is people are pretty much comfortable with Python. I can understand that, but just to bring out a new flavor, I thought of getting it in terms of JavaScript so that people can sort of expand their horizon. Doing this in Python is a very easy task, but once we do it in JavaScript, there are certain things which have to be built, and which sort of helps us understand the concept of blockchain and cryptocurrency in a greater depth. One sec, I think there's a message on the chat. Okay, okay, thank you, Ritom. So first of all, we'll start with creating a block. So I'm just going to explain what we're going to do right now. Is that first, our basic idea is we have to start building a blockchain, and the building blocks of the blockchain is a block. So we're going to start off with building a class block. I hope you guys are a bit familiar with what a class and object is, but even if you aren't well versed with it, no worries. I'll be explaining them in a very little detail. So what should our block actually contain? Those things will have to create it in a constructor. So a basic constructor means that you take in some data and you assign the properties to the block itself. So we'll write down constructor. And what are the basic things required in a block? What all does it keep track of? Are we'll take index just for this example. It's not really necessary in every cryptocurrency to have an index, since we are going to be tracking the blocks by previous hashes. But just for our sake, we're going to start off with index. We need a timestamp at which the block was created, the data which it will be holding. Suppose in terms of cryptocurrency, we'll be storing the transaction details and the previous hash. And by default, I'm going to keep the previous hash as empty. Whenever there's going to be a new block created, at that point, we'll be assigning the previous hash. So once we have defined all those data, all those properties in our constructor, we have to assign it to the block. And the way we do this is by using the keyword this. So this dot index equals index. So basically, I took the value index over here. I took the value index and I assigned it to the block. So this dot index equals index. I'm going to repeat that for every other data. So this dot timestamp equals timestamp. This dot data equals data, and this dot previous hash equals previous hash. So I have kept it as empty by default. In case if a previous hash is passed, then only I'll be assigning a new value to it. So why is it empty by default? As Ritom explained earlier, the first block in a blockchain is the genesis block, which doesn't particularly contain a previous hash. So that is why by default it should be empty. But in case if there are new blocks added to an existing blockchain, then only we'll be passing the previous hash so as to connect it to the blockchain. Uh, okay. And the most important thing about block is its hash value. So its own hash value will be actually calculating it. So I'm going to create a function called calculate hash. This function hasn't been made yet. I've just written it down. So once I'm done writing the function, then only it will be usable. Okay. Is my voice audible now? Is it clear? Can anyone confirm if my voice is clear?
Yeah, Aniket, it's fine
Yeah.
now.
It's fine. Okay.
Yeah.
Yep. Sorry for the disturbance. So for our own cryptocurrency, we'll be using the SHA 256 algorithm. For now, we're not going to be going in very depth regarding the working of the algorithm. So we are just going to use a package called SHA 256. And for that, we have to install it. So I hope you guys have Node installed. So what you simply do is just pull up your terminal like this from below. So your terminal will open up. And over there, just run the simple command npm install dash save crypto dash js. So I'm just gonna explain this line. npm is basically Node package manager. You guys have, I hope you guys have installed Node as mentioned in the email before. So Node package manager will provide us with crypto.js. It's a folder which contains all the different cryptography algorithms. So by default, JavaScript doesn't provide this, so we have to externally install that into our own system. I'm just gonna press enter. Yeah. So added one package. I'm just going to wait for a while. If anyone has any doubts in installing this, please put up in the chat. And if there aren't any, I'll continue. Does anyone have any doubts? Okay, so I'll be using the SHA-256 function over here. So I'm gonna first include that. So I'm gonna be defining a constant called SHA-256, which requires the package as installed by node modules. It's gonna be in crypto.js slash SHA-256. All right. Yeah. So I'm going to start writing this function. So when you want to write a custom function in your own class, you just write the name, which is calculate hash. Okay. Yeah. So once you have declared your own function, we have to write what we are going to be. Please tell me the channel name. You can simply search Bitgrid. Yeah. Thank you, Shubham. So while calculating a hash, we have to provide the SHA-256 algorithm certain parameters. So what we're going to be doing is we'll pass the index, the previous hash, the timestamp, the data, all of those together to the SHA-256 function, and that will return a hash. So in order to do that, we're going to write return SHA-256, and to this we are going to pass all the data we have to use to make the hash. So we'll start off with index. We'll take the timestamp, the previous hash. Sorry. And for now, we haven't declared any nonce, but we'll be doing that soon. And I'll be explaining why the nonce is really important. Ritom has done that, but I would be showing it how it is going to be affecting our code. Our data is mostly going to be in a JSON format, so we have to convert that to string. So we're going to use JSON.stringify. Don't worry, guys. If you have any doubts regarding the function, each function, you just put it up in the chat. We'll be covering up them soon. Then we are going to be stringifying our data. Okay. So once this entire thing is done, we'll convert it to a string. So, all right. So we have defined our block right now, and it has a function called calculate hash, which is going to return a hash by using the SHA-256 algorithm. And the data passed to it is the index, the timestamp, the data, and the previous hash. I'm just going to wait for a couple of minutes so that you guys could just copy the code if you guys are working on. Yeah, let's continue. Since one block has been created right now, not one block, sorry, the template of the block is ready right now. We have defined the class of how each and every block should look like. It should have an index, timestamp, data, and the other details. Now we have to create the chain. So we have to create a class called blockchain. I'm just gonna write another class, chain, and it's going to contain its own constructor. We don't really need anything in the parameters. We have to just create the chain. And for creating the chain, we are going to be using an array. I hope you guys are aware with what an array is. So this dot chain will be equal to, let's keep it empty for now. Uh, yeah, let's keep it empty for now. Okay. So first we have to start creating by our Genesis block. We have to create our Genesis block first. I'm just going to write a function for that called create Genesis block. Uh, just to revise, a Genesis block is the first block in a blockchain. So it doesn't have any previous hash since it itself is the first hash. So what we'll do is we're going to pass the data. We're going to return a new block. Okay. So whenever a blockchain calls this function called create Genesis block, it will create a Genesis block and it will return it to the source. So how do we create a new block or create our Genesis block in this case? Is we simply put new block, all right? So just to tell you that this block is actually our class itself. We are starting to build our chain, and now we have to create the first block, and we have a template of the block ready on. So we are going to be passing the required properties required. So index, let's start it with 0. So that's going to be our first. Coming to timestamp, let's just put today's date for now. And the third parameter is data. So well, let's just make this a bit simple. We're going to name it Genesis. The data inside is Genesis, and the previous hash will keep it 0 for now. Okay. So now the create Genesis block function has been defined. Now what we're going to do is we're going to call the function inside our array so as to initialize the chain with the Genesis block. So I'm just going to write this dot create Genesis block. Okay. So what does a constructor do? Whenever you create a chain, a blockchain in this example, so whenever you create a blockchain, the constructor will be the first thing to be called. The constructor initializes all the data you have already provided. It's going to initialize. It's going to set your blockchain. And what is the code inside? We are starting our chain. Our chain is going to be an array, a list of elements, and the first element is going to be our Genesis block. So the first element is going to be this dot create Genesis block, and that is a function. And that function is actually defined over here, which will return a new block with these properties assigned to it. And just mind you that this block is actually the block we have already defined. All right. So I believe we have our blockchain template ready as well. So okay, we forgot to actually finalize the name of the cryptocurrency. The last thing I remembered was Sigma as yes. So let's just name it Sigma for now. Now that the blockchain is ready, we are going to start putting out our own cryptocurrency. Right? So in order to create an object of a class, while we creating an object of a class is like a template. So the template for a blockchain is ready. What is the template? It has a constructor which creates the Genesis block, it starts the chain. Right? So now we need an object to be the actual representation of that template. So we're going to use the variable we are named a coin sigma. I'm going to call it let's sigma equals new blockchain. Yeah. All right. So as you can see, our coin has been sort of created. Our Genesis block will have been created once we call the blockchain over here. So I'm just going to console log this out over here. Console.log is a function which actually just prints whatever data you're going to pass it through. It's just like a print statement in regular coding. So I'm just going to stringify it. Yeah. So our data over here is we have to print sigma. I'm going to be explaining this parameters, guys, so don't worry. Let's just check our output first if our code is actually working or not. Okay. So in order to test your JavaScript code, so a little bit about JavaScript. A JavaScript was initially built to handle all the code on the front end. Suppose any like if there are form validation. So before you submit your form to the actual server, you would like to sort of validate the form in the browser itself. So that is how JavaScript comes into the picture. It performs all those operations in the browser. What Node.js does is it sort of provides a terminal for you so as to test your JavaScript code in the terminal itself, and instead of just making an index HTML again and again to test your code on the browser. That is what it does. And you guys can see as soon as I executed my code, console.log is a print statement, and I'll be explaining this line, guys, don't worry. I just wanted to focus over the chain we have built over here. All right. So the data over here is our chain, this variable, okay? And the first block created over here is the data, right? So as you can see, the index is 0, the timestamp is today's date, the data is Genesis inside, previous hash 0, and the hash over here has been calculated by the SHA-256 algorithm. All right. So I'll just re-explain the flow. So I started off by creating a coin called Sigma. It called the blockchain class, and what happens over there is it's going to initialize a chain. Start off by creating a new Genesis block, and when you call this new block, which is essentially over here, so it's going to take all those index, timestamp, attributes, data, previous hash, and all those things. It's going to take over here as its own property. And when you call the function calculate hash, which we wrote over here, it's going to return the SHA-256. It's going to take all those data which we use, index, timestamp. It's going to add all of them and return the SHA-256. It's going to run the SHA-256 algorithm on it and return a hash value accordingly. And so basically, when we added our index and all those other properties, this is the hash value which was generated. Okay. So right now, a basic template of our cryptocurrency has been made. Now we gotta start with adding blocks in our blockchain. So before that, we'll yeah, sorry. So once we start adding our blocks, we're gonna later on look at the concept of proof of work and all. Right now, we're gonna make adding very simple. Adding a new block to your blockchain, we're gonna keep it simple for now, just for testing purpose. So it's not at all the best solution, but yeah, we're gonna make it real simple. So I'm just gonna make a one second. I'm just going to make a function called add block. Simply, it's going to add a block, and in the parameter, we have to send off. The audio is not clear. Is this a problem with everyone? Is it clear now?
Yeah, it's clear now.
Yeah. Okay. Thank you. So the parameter, I'll be accepting the new block which has to be added to the chain. Okay. Yeah. Sorry, I just forgot to explain this little piece of code over here. So as I said, console. I'm just going to put spaces so as to make it look a bit more neat. So a console.log statement is simply just to print out the data passed in it, and JSON.stringify, what it does is it basically converts it into a string. So if we have a JSON format, so stringify, it will just make it into a string which can be easily printed.
Aniket,
yeah, hello.
your voice is cracking a bit, so if you can keep your microphone a bit closer, it'll be better for the participants, I guess. Yeah.
Okay. Is the voice better right now?
Yeah.
Okay, thank you. I'm sorry, guys. Yeah. Can you mute the mic, please? Okay, thank you. Sorry for the disturbance, guys. I hope my audio is clear right now. So yeah, console.log is basically gonna print out the data. Stringify is gonna convert that JSON. JSON is a type of data, and it's gonna convert it into a string which can be easily printed on the terminal or on the browser or wherever required. Okay, and the parameters passed to it is, first of all, it's going to be sigma, the thing we have to print. The second parameter is null, is basically if it's an integer, it's a string, or do you want it to uh, sort of detect itself. So I put null because I wanted to detect itself without me caring how it has to be printed. Okay, and 4 is simply the number of white spaces, so as to make your data look a bit more clean on the terminal. So I decided on putting 4 white spaces so that the data is sort of clean on our terminal. This doesn't have to do anything with our functionality of the blockchain, so you don't have to really worry. Okay. So getting back to adding a new block, so over here we're gonna write this piece of code over here. So basically the new block is gonna do one thing. The first important thing while adding a new block is to make sure that the previous hash value of the new block is set correctly. Okay, so for that what we're going to do is we should create a get latest block first. So what this function is going to do is, one sec, this function is going to do is it's going to return the latest block, the last block which is onto our blockchain, so that when we are adding a new block, it's going to take the hash value of that particular latest block and make it its own previous hash. Okay, so how do we get the latest block? We simply return the last element of the chain. And how do we do that? Since it's an array, so it's going to be the length of this chain minus 1. So I hope you guys are familiar with zero indexing, that counting in arrays and basically the entirety of computer science starts with 0. So the last index will be the length minus 1. Since we are counting from 0, the last element will be the length minus 1. Okay. So this way we're going to return the last latest block, and the previous hash of the new block, it's going to be this dot get latest block dot hash. So let me just explain this over here. So new block dot previous hash. I think you guys understood this. We have to set the previous hash of our new block. And how do we do this? Is first we get the latest block, which is returned by this function over here, and we want the hash of the latest block, so as to put it in our previous hash. All right. Yeah. So now we can, I think our block is now ready to be added. So what we can do is simply new block dot push. All right. I'm sorry, not new block dot push. It's going to be uh, this dot chain dot push. So what does push do is basically it's going to take the element which has to be passed in the array. In this case, it's going to be new block. Okay. So it's going to push the new block at the end of the chain over here, and it's gonna like sort of establish that yes, it is added to our blockchain right now. It's gonna simply append it to the end of our blockchain. All right. Yeah. So I'm just gonna give a couple of minutes so you guys can be up to date with this section of the code. Okay, so let's continue. I hope you guys are up to date with the code over here. All right. So yeah, by default, we have actually missed out one line. I just forgot to explain that. Okay, let's go through the flow once. Okay, what I'll do, I'm just gonna write the code, and later on we're gonna find what our error is. Okay. So let's create a block called block one simply, and it's gonna be a new block. And the first thing is going to be our index. So since we have already established 0, now we're going to start with 1. Our timestamp, well, I'm just going to put yesterday's date maybe. Data, let's start building the basics of our cryptocurrency. So for now, I'm just going to pass an amount, which is going to be the amount of currency we're going to be passing. And for now, the previous hash, it is kind of empty. It is empty. Yeah, because we don't know it's going to be calculated later on. All right. Yeah. So now, what is our main issue with our block right now is, okay, once I have written this piece of code, it's gonna go create a new block, right? And it's gonna put all those values over here, it's gonna calculate the hash and pass it over here, okay? But there is one problem, is that we still haven't assigned our previous hash. Our previous hash is currently empty, all right? So when this thing is called in the beginning, it's going to calculate the hash with assuming that the previous hash is empty. It's going to pass it over here, and it's going to return maybe a wrong hash. So over here we have added our actual previous hash. So what I'll do is I'll just going to recalculate my hash like this. Okay. I hope you guys understand. Earlier we didn't have a previous hash, so whatever hash was calculated was incomplete. So now when I have my previous hash for sure, I'm going to recalculate the hash and assign it to the new block. And this thing, we're going to be pushing it in our blockchain. All right. So now that block one has been created, we haven't added it per se. So we're going to put Sigma. Sigma is our blockchain dot add block. And over here, we're going to pass the parameter block one, which is our first block. Uh, by first block, I mean after the Genesis block, right? So what we'll do is we'll just print over here. Once it has added, it is going to print it over here. I'll pull up my terminal. Okay, and just rerun my code. Okay, so I again run my code main.js, and now you can see that our chain value has changed. The first element of our chain is the Genesis block, which I had discussed previously. And now we have added our new block to the blockchain. So index is 1, timestamp is yesterday's date. We have our data, which is the amount. And you guys can see over here that the previous hash is 009827 and so on and so forth. The previous hash value of this block is this 0099, and the hash value of our Genesis block is 099. So it is correctly storing the previous hash, and this is the new hash generated after it has gone through the process of recalculating after getting the new previous hash. All right. So let's just add another block for just an example. So I'm just going to copy paste, name this block 2. I'm going to add block 2, make this related changes. So this is as 10, amount is 20. Right. So I save my code, and now I'm just going to run it again. Right. So now a third element has been added to the block. So you can verify manually that the hash of this index 1 block is 8D0D, so on and so forth. And the previous hash of our next block is the same as well. So it is verified. All right. Now let's write a small piece of code so as to verify if our chain is, our chain is valid or not. All right. So there are two things which we have to verify. Okay. I'm just going to give you guys 1 minute so as to you guys can sort of soak. And if you have any questions, just ask it right away. Okay. There's a question from Ashish. Ashish, you said that would not the constructor create the hash itself? Yeah, I'm just going to explain that again. So when we write this piece of code, right now our previous hash value is sort of null. We do not have a previous hash. We don't know the previous hash before adding it to the block. Okay. So right now it is empty. So whenever we call the constructor, basically when you create an object, the constructor is called. So when the constructor is called, this particular this dot hash function is called, which calculates the hash. Okay. So we have our index correctly, we have our timestamp correctly, we have the data correctly, but we do not have the previous hash. Before, when the constructor is called, at that point we do not have the previous hash assigned to that particular block. When do we have a previous hash assigned? It happens only when we call add block, because add block contains the code to get the latest block and assign the hash accordingly. Okay, so new block dot previous hash is the hash of the latest block, and that is why I have to recalculate my hash so as to get the latest hash value, and that I will be pushing into the chain. Okay, I hope it was clear, Ashish. Okay, thank you. Okay. Yeah. So moving on, I'm just going to check for the validity of my chain. So I'm going to make a function called, let's just push this down for a while. Okay. Yeah. So let's name it is chain valid. It's going to return a true or false. Okay. So basically what do we have to check in our is chain valid is first of all, if someone randomly enters the blockchain, we have to make sure the first check would be is the comparison between previous hash and the hash of the variable uh, hash of the block we have. So that is going to be our primary check. So what we'll do is we're going to loop over the entire blockchain. So we're going to start with 1 because we are not counting Genesis for now. Okay. So for let I equals 1, I is less than this dot chain dot length, yeah, and I plus plus. This for loop will let me iterate over the entire loop. Okay. So sorry, entire blockchain. So I'm gonna store two things. First thing is the current block. So just let current block, which will be this dot chain at I. Okay, this it will be storing the current block, and we're going to store a let previous block, which will be this dot chain at I minus 1. All right, so we have the current block and we have the previous block as well. Okay, so the code is going to be very simple. It's going to be if current block dot previous hash is not equal to the hash of the previous block. Okay, we're going to return false, because I hope it makes sense that if the previous hash of our current block is not equal to the hash of the previous block itself, it means someone has tampered with our blockchain. Okay, so we're going to return false. Okay, all right, that is one check, and yeah, and the other check is going to be we are going to sort of recalculating the hash to verify if it is actually are the correct hash value or not. Okay, so a simple piece of code: if current block dot hash is not equal to current block dot calculate hash, we're gonna return false over here as well. All right. And in case if it doesn't return false in any of these looping, so we're gonna return true over here at the end. Okay. So yeah, bringing this back up. I'm just gonna console log sigma dot is chain valid. Yeah. So right now we haven't done anything as such to tamper with our block, so this should be fine right now. Okay. So I'm just gonna rerun this, and yes, it's obviously true. Okay. I'm gonna give you guys a few minutes to just rewrite read this code and sort of copy it if you are lagging. Okay, so let's put an example if we could how we could sort of tamper with our blockchain and if it detects it or not. Okay, so these are simple two blocks which we have created and added already. So let's do one thing is we're gonna console log the validity of the chain here. First check. Okay, all right. And after this, what we'll do is let's make a random edit to our block. Now, suppose I'm the owner of block one. Let's assume it that way, and I'm a greedy person. So what I'm gonna do is what I'll do is suppose I know this is going to be my chain. Okay, sigma dot chain at one, which is my block dot data. I just make it, I want to be rich. So it's 10 right now. I'm gonna make it 2000. This is a perfectly valid code, but this is tampering with my blockchain. So what I'll do is I have done this. I'm gonna run a check again on my blockchain. So this is going to be my second check, which will be post tampering. Okay. So now let's run this code. As you can see, the first check was true. That time, all the blocks were adding in a sort of conventional way, the way it is defined to be. But the second check over here shows false. Why? Because I'm going to explain how it happened. So I tampered the data over here. Okay. So now the value of my block has changed. Okay. It has the amount 2000 over here. Okay. That thing is fine. But when we call the is chain valid function again, yeah, over here. So this thing is not giving us a problem. I'm sorry, this thing is not giving us a problem. Nothing has been done to the hashes, so that part is not really affected. This is the essential piece of code which is returning false. So current block dot hash, okay. So current block dot hash is storing our previous hash value when the amount was 10. So the hash value returned using that data is 10. But when I recalculate the uh, hash of my block, that time the amount has been tampered. It is 1000 at that time. The amount is 1000 at that time. So this returns a different hash value. I hope you guys understood. So since the amount was tampered, a new hash was created and it did not match with the previous hash. It means our block was tampered. So it's going to return false. All right. So this is how we have checked our validity of our uh, chain. Are there any questions? Yeah. So guys, I'll just like to give an overview. I know we haven't really built a proper cryptocurrency yet where we are making transactions or doing all those things. But I hope you guys can understand that this was absolutely essential so as to get the concept of what is adding a block to your blockchain, checking the validity of your blockchain. So all these necessary steps had to be taken. And now we can sort of start building our cryptocurrency based on the amount of code we have written till now. All right. So if you guys have any other doubts till what I have done till now, please feel free to put it in the chat box. I'm just gonna give you guys a minute. Yeah. Okay. So guys, we have our basic blockchain ready. We have designed the block components on how it's gonna be working. We used SHA-256. We created our Genesis block over here, which is going to be the start of our blockchain. We wrote a code so as to check for the validity of the chain so that no one just randomly makes themselves rich. Okay, so I guess that's going to be it for today. This doesn't essentially mean the end of our webinar series. In the next webinar series, we'll be building more out of our cryptocurrency based on the code we have written today. So I'll be pushing the code onto my GitHub. So if any of you guys missed or would like to continue next week on the same code, you can check out the link. Ritom had actually linked my GitHub repo on his PPT. So make sure you guys download the PPT over there, and you can refer the link. I'll resend the code. I'll resend the link. Okay, thank you, Ritom, for doing that. So I'm just going to give you a brief idea what we are going to be doing next week. Okay. So in case of a cryptocurrency, this amount of data is definitely not sufficient. Okay. So what we have to do next week is, first of all, before changing the amount or any other properties, the first most important crux of our cryptocurrency is going to be the proof of work. Okay, so we're going to write a basic code next week which is going to be which is going to be checking for that if you have sort of dedicated that much amount of computational power so as to get into our blockchain. And we're going to be deciding a bit of reward system. And before designing a reward system, we are going to make a proper transaction data. Okay, so right now it is just amount 20, amount 10, which doesn't make much sense. Actual cryptocurrency in the most basic form contains the sender's address, the receiver's address, and the amount of data, amount of coins which have been transferred. So we are going to look at that, and we are going to implement proof of work in our code, and we'll actually understand what it takes to sort of mine these cryptocurrencies. Okay, so Once again, I'd like to repeat that today we have built the basic blockchain. We have built the blocks. We have now understood how a blockchain actually works. And we have sort of started with our own cryptocurrency Sigma. We'll continue with the same name next week as well. And we're going to build more out of it. We're going to put transaction details. We're going to put mining rewards, and all of those things. We'll be doing it next week, because right now my main motive for this webinar, for this hands-on session, was to get you guys comfortable with the concept of what is a block and what is a blockchain. Thanks to Ritam, he explained all the theoretical sections, where you guys have now have at least you have a presentable idea of what exactly a blockchain is. We built a basic cryptocurrency system over here. We're going to add more complexity in the future webinars. Does anyone have any doubts? Anything related to the code or Ritam's presentation or anything?
Hey guys, I'm sending the link to the skill sheet form also. So if you're interested in data science job openings or anything related to that, so BitGrit can get in contact with you if you actually fill out your details on this. So yeah, it's a Google form, so you can just fill it at your convenience. If anyone has any questions, then please feel free to ask. Okay, so there are no questions as such which I see coming up. In fact, if you have any questions even in the future, then you can connect with either me or Aniket. I mean, we're both on LinkedIn. You can just search in our names on LinkedIn and you'll get our profiles. You can message us there also if you like, and if you don't want to like really speak out here. So you can also like contact us on our individual profiles. We are pretty much active on all platforms. So you'll be sure, like rest assured you'll get an answer to your doubt.
Yeah. So regarding my contact, you can just visit my website aniketraj.co. I'm going to just put up the link over here. So over there you can find the IDs, the all my social media. Okay, one sec. Yeah. This is my website. You guys can visit me over there. Over there, you can find the links to all my social media. Feel free to connect with me on LinkedIn, Instagram, any other platform. And if you have any questions regarding the code, regarding blockchain, even if it is related to data science and any other technological stack, feel free to contact me or Ritam with any doubts. We would love to help you with that. Okay.
Yeah, guys, so about the skill sheet which I shared the link to, so it's basically like you can fill in your skill sets, whatever what technical stuff you've worked on before, what are your technical interests. So we can BitGrid can actually get in contact with you regarding the future job opportunities and competition details and as such. So you'll also be eligible to participate in data science and AI competitions. So yes, if you feel that you really do want to be a part of this, then please do go ahead and fill out your details on the form.
Okay. Thank you guys for joining in on a Sunday. I hope you guys join in next week also, where we'll be completing our cryptocurrency. The base has been created right now. The rest of the code and explanation will be done next week. Okay. So thank you, everyone.
Thanks, guys. Thanks.